13 asks which compound has polar bonds but is nonpolar overall. In order to do this, we definitely have to be able to understand the geometry of the molecule, because in order for something to have polar bonds but be nonpolar overall, that means that the bond dipoles are canceling out in a very specific way. So let's draw all of these with accurate molecular geometry. First, we have ammonia. So we have NH3. Then B is CH2Cl2. That is going to be tetrahedral. C is CH4, and then D is CO2. So that one is going to be linear because we have two groups. Whenever you have two electron domains surrounding a central atom, that will be sp hybridized and therefore linear. So the question asks, which compound has polar bonds but is nonpolar overall? Well, the first one we can get rid of is methane because that does not even have polar bonds, right? So if there are no polar bonds at all, the molecule cannot be polar. The rest of these molecules do have polar bonds, but which one of them would be nonpolar overall? So here for ammonia, we have 3 polar NH bonds, and they're all pointing sort of downwards with respect to the nitrogen atom. And so we do end up with a dipole there. We have a dipole where there's an end of the molecule with the partial positive hydrogens, and there's an end of the molecule with the partially negative nitrogen and its lone pair. Then if we look at CH2Cl2, we have a similar situation where we have 2 bond dipoles. So there is a net dipole. When we combine them, we do get a net dipole. It is slightly diminished because of the adding of the 2 vectors, but the 2 vectors are pointing somewhat in the same direction. So we can combine them. We can get an overall net dipole. So we do have a polar molecule overall. But if we get to CO2, we have a polar CO double bond. We have a polar CO double bond going the other way, but because they are precisely opposite in direction, they are equal in magnitude and opposite in direction, this is going to be nonpolar overall. The only way for this to have been polar is that the bond dipoles could be not of the same magnitude. So for example, if we replaced one of these oxygen atoms with a sulfur atom, then we would retain some overall dipole because the magnitudes would be different. We would have one bond dipole being longer and stronger than the other one, so it would retain some polarity overall. But these are exactly the same. It's C double bond O and C double bond O. If they were pointing in different directions, then we could retain a net dipole just like CH2Cl2. But because they are of the same magnitude and in precisely opposite directions, they cancel out completely. So CO2 is an example of a molecule that has polar bonds but is nonpolar overall.